Okay, Mr. Antonucci here, and our third video is calculate a confidence interval for the slope of a population regression line. So when the conditions are met, in the last video we talked about the conditions, the sampling distribution of the sample slope B is approximately normal with the mean of B equal to beta and the standard deviation given by this formula. Most of the time, we won't know the standard deviation of the residuals for the population, so we'll use this formula to approximate it. We also won't know the standard deviation for the population of X values, so we estimate it with this formula. So our resulting estimate for the standard deviation of the sampling distribution of B is the standard error of the sample slope B, which is given by this formula, where S is this and X is S sub X is given by this formula. So we interpret S sub B like any standard error. It measures how far the sample slope typically varies from the population slope if we repeat the data collection process many times. So when the conditions are met, we can make a C% confidence interval for the slope beta of the population regression line, and it's just B plus or minus the T star critical value times the standard deviation, B, where T star is the critical value for the T distribution, and get this, N minus 2 degrees of freedom, and C% of the area between negative T star and positive T star. So the specific formula for confidence interval for a population slope is not included on the formula sheet for both sections of the AP Stats exam. However, the formula sheet, like we've said before with all this inference stuff, does include the general formula for confidence interval, which is always going to be the statistic plus or minus the critical value times the standard error of the statistic. And it's also going to have the formula for the standard error of the sample slope. So this will be in the formula sheet as well. Okay, so you just have to know when to use them and how to combine them and then interpret the results. So if we go back to that example about the breast diameter at breast height of the 40 selected ponderosa pines in western Montana, we have a computer output summarizing the relationship between X and Y for those trees. Now remember, X equals the dBH in inches and Y equals the height in feet for those trees. If we want to calculate a 99% confidence interval for the slope of the population regression line. So here we go with 99% confidence, we'd have degrees of freedom 40 minus 2, which is 38. And then the formula for the confidence interval would be our slope B, which is 2.6181, which is we got that from the computer output, plus or minus our T star critical value, which is 2.712. You could use inverse T on the calculator, or you could also use the T table to calculate that in either way. Now, table B, you're going to have to use 30 degrees of freedom, and the T star critical value is going to be 2.75. So the confidence interval from the table is going to be slightly different that you end up with, but it's still a valid way to do it. But here, our confidence interval is 2.0643, comma 3.1719. Now, we ask, does the confidence interval in Part A, that answer, provide convincing evidence of a linear association between dBH and height in the population of ponderosa pines? I'm going to explain our answer. Yes, it does, because all of the plausible values for beta in the interval are different from 0. So there is convincing evidence of a linear association between dBH and height in the population of ponderosa pines. Now, we want to know, how do we calculate, or excuse me, interpret that confidence interval? here's how we do it. If the U.S. Forest Service took many, many different random samples of 40 ponderosa pines in western Montana and constructed a 99% confidence interval for the slope beta of the population regression line for predicting height in feet in dBH from dBH in inches based on each sample, about 99% of those intervals would capture beta. So when you are interpreting the 99% confidence level, you're not interpreting the interval. Remember, those are two things. In part B, we interpreted the interval sort of there, and in C, we interpreted the confidence level. So just make sure you have a distinction there. Now, another thing is the values of t given in the computer regression output are not the values for a confidence interval. So these t values right here are not to be used as the t-star critical value. And that's our tip on the AP Stats exam. You might be tempted to use the t-test statistic from the computer output as your critical value for a confidence interval. The value of t in the computer output measures how far the sample slope is from zero in terms of standard errors, but the t-star critical value measures how many standard errors we need to go from the mean to have the C% confidence interval of the area under a t-curve with the specified degrees of freedom. So to help avoid this error, we're just going to use an asterisk to denote the critical value t-star. Okey-doke. All right, guys, that was it for this video. Hope that was helpful to you. Reach out if you have questions.